Number 1, it says write y equals -3, parenthesis x minus 2, parenthesis squared, plus 7 in standard form. Well, it's currently in vertex form. Okay, this is vertex form. They want it in standard form. Standard form looks like this. Correct. That's not really a formula. Okay? Yeah, like see this one in number 1, that's in vertex form. Number 2 is in standard form. So what's number 4 in? Standard. Okay, look, vertex has parentheses. Standard does not. So number 5 is standard. Number 6 is vertex. Okay. Now, it has been a while since we've done these, like a couple of weeks, but I'm hoping once I go over it, you'll be like, oh, I remember that. Okay, so watch. The first thing we do to convert it from vertex to standard form is we rewrite it. Now, there is going to be a minor change. Instead of writing x minus 2 squared, I'm going to go ahead and write it out twice because that's what squared means. It means it's multiplying by itself. Now, the reason I do that is so that in the next step, I can distribute the x times x, the x times -2, and then the -2 times x, and the -2 times -2. Now, when I distribute those, does it affect this -3? No, so I'm just going to bring it down. Does it affect this plus 7? No. So what is x times x? X times -2. And then -2 times x. And -2 times -2. Positive 4. Okay, so then in the very next step, I can combine like terms. Okay, see how this has a -2x and another -2x? Those can combine to a -4x. Now, is combining those going to affect this outside -3 or the outside positive 7? No, so I'm going to continue just writing those where they are. I'll use those last. So now what does this become when I combine those like terms? So x squared minus 4x plus 4. Okay, now that that is as simplified as you can get it, now what can you do? Now you can distribute the -3 to everything in the parentheses. So y equals -3 times x squared, which is -3x squared, -3 times -4x, which is positive 12x, and -3 times 4, which is -12. But then look, when you bring that plus 7 down and add it to that -12, what does that become? What's -12 plus 7? -5. And now isn't that in the form ax squared plus bx plus c? So now it's in standard form. I know it's been a couple of weeks, but now don't y'all remember us doing a lot of those? Okay? So look, all you have to do is rewrite it. But when you do that, you write this out twice because that's what squared means. Then after you have it twice, you're ready to FOIL it, or some people just call it distributing. And you get that. Well then, before you're ready to mess with the -3 and the 7, you can combine the like terms in the middle. And then once you've done that, then you distribute the -7, and the last step would be, -3, and the last step would be to add the 7. Question 1 on the test is just like that. So if you don't know how to do it, you need to go home and watch this video over and over this weekend until you know how to do it. Guys, you can even make up your own problems. Like you can make up a new equation by changing this to a different number, changing that to a different number. All you got to do is go in and change numbers, change signs, and you have a new one you can practice with. Okay? You will have one just like that. It'll be number 1 on your test. So I would go home and make sure you know how to do it by watching the video and by practicing. Okay, number 2. Which of the following quadratic equation, or write the following quadratic equation in vertex form. So this time, they gave us the equation in standard form. They want it in vertex form. Well, the easiest way to do that is to graph it. So go to y equals and graph the equation. It's x squared minus 6x plus 2. Okay, when you graph it, you're able to see where the vertex is. Where is the vertex of that parabola? Okay, over 3, down 7. So that means the vertex is 3, negative 7, correct? But you have to remember how to write it in vertex form. So y equals, to represent it moving right 3, how do you represent that in the equation? X minus 3 would be right 3, correct? It's always the opposite of what you would think. X minus 3 will shift it right 3. And then you square it to make the parabola. And then to make it go down 7, what do? Minus 7. So really, guys, all you have to do is graph it, locate the vertex, and plug in those numbers. Your x value, though, is always the opposite sign. Since it was positive 3, you put x minus 3. Your y value is what it is, minus 7, so minus 7. Okay, here's another way to do it. You could do negative b over 2a. That's fine. What is your current b value in this equation? A negative 6. So won't that become a negative 6, which is just 6? And then what's your current a value? Your current a value is 1. Isn't that a 1x squared? So 2 times 1 is 2. Okay, and x equals this. So x equals 3. Well, didn't we find that by graphing it? Now to find the y value, you just plug in 3. What's 3 squared? Minus, what's 6 times 3? And then plus 2. What's 9 minus 18? Negative 9. And what's negative 9 plus 2? Well, didn't we get that when we just graphed it? So you can do it either way. If you don't want to have to graph it to find the vertex, you could do this way, which is where you do x equals negative b over 2a. You get your x value. You then plug it in to find your y value. Either way you want to do it. Well, yeah, I do too. It's less to remember. The only thing you really have to remember once you find the vertex is that this one will have the opposite sign. Okay, number 3. Write an equation of a quadratic in standard form that has a vertex of negative 8, 3. Well, think about it. If its vertex is at negative 8, 3, what kind of shifts did it make? Well, negative 8 means it moved what direction? It means it moved left 8, right? If it ended up negative 8, that's left 8. Positive 3 means it moved up 3. So to write that in the equation, pay attention. To write that in an equation, left 8 would be represented with a x plus 8. And then up 3 would be plus 3. However, that's not the answer because that's vertex form. They asked for it in standard form. So now are you going to have to go back and do what we did with number 1? Okay, so take a minute and try it by yourself now that we did one together. Okay, so let's look what I've done so far. The first thing I did was I took it from vertex form and I just rewrote it, but instead of writing x plus 8 squared, I wrote it twice so that I could distribute it out. X times x gave me the x squared, x times 8 is 8x, then another 8 times x is 8x, and 8 times 8 is 64, and then I brought the plus 3 up. Now I'm ready to just combine like terms. The 8x and 8x will become 16x, and the 64 plus 3 is 67. And so now is that in standard form? Okay, now let's check and make sure we've done it right. Let's graph our answer. Y equals x squared plus 16x plus 67. the vertex of this parabola? 1, 2, 3, 4, 5, 6, 7, 8. So negative 8 and then up 3. Well, look, negative 8, 3. That means it's the right equation because it gave us a parabola with a vertex at negative 8, 3. So if that was multiple choice, even if you just really couldn't do all these steps, couldn't you graph each choice until you found the parabola with a vertex at negative 8, 3? All right, number 4. Find the domain. When you hear the word domain, what do you think of? Right. Okay, so when you're writing out your domain, what do you put first? Left or right? Left. You always go from the negative side to the positive side. So you'll write the left and then the right. Okay, well, to be able to do that, don't we kind of need to see a picture of this, a graph of this? So y equals negative 3x squared minus 2x plus 1. Okay, so there's the parabola. How far, like if you try to go left on that parabola, how far left can you go?
25.
Forever to the left, which yes is negative infinity. Think about it. As it's going down, aren't you also slowly moving left as well? And will continue to do that forever. So that's negative infinity. How far can you go to the right? Positive infinity. So the domain is negative infinity to positive infinity. It goes left forever and it goes right forever. Okay, what is the axis of symmetry for the graph defined by this function? Well, what are they talking about when they say axis of symmetry? Well, a line that will do what to the parabola? Split it in half. So don't we need to see a picture where this parabola is? So y equals negative 2x squared okay. When we graph it, where would we need to draw a line to split that parabola in half? At 2. The x-axis at 2, right? So how do you write the equation of a line that goes through the x-axis at 2? That's a point. How do you write the equation of a line? X equals 2. Okay, the equation of a line that cuts through the x-axis at 2 is just x equals 2. Alright, number 6. What is the range of the following quadratic function? Well, when you hear the word range, what do you think of? Y values. Okay, well, with domain, we do left and then right. With range, we do... But which one first? Down and then up. Okay, so we see how far down the graph will go and then how far up it will go. So let's graph it so we can see a picture of it. Y equals negative 2 parenthesis x plus 2 squared minus 6. Okay, if you're on that parabola and you want to go down, how far down could you go? Forever. So negative infinity. No, for domain, yes, but not for range. Because think about it. If you're on this parabola and you want to go up, how far up could you go? Wouldn't that be the highest? And what's that y value? How about count it out? Negative 6. And think about it. That was caused, look at the equation. Didn't that minus 6 on the end of the equation cause the vertex to move down 6 units? So that's why you're only able to get up to negative 6. And you put a bracket there because you have to stop there. In this, yes. Well, it just depends. It just depends. Okay, number 7. We got to get one more done. Number 7. Which of the following is not true? Okay, I would keep paying attention. You can pack up in a second. Which of the following is not true of the graph of y equals ax squared minus 6x plus 4 where A is greater than 0. What do they mean when they say where A is greater than 0? Your A value has to be a number greater than 0. So could A be 1? Could A be 2? Could A be -5? No. So why don't you just start by graphing that equation, put in the A place, put a number greater than 0. So just start with 1. So 1x squared minus 6x plus 4. Once we have a picture of it, we should be able to answer the question. Okay, we're looking for not true. The graph is a parabola. That's a parabola, so that's true. The y-intercept is positive. That's true. Your y-intercept is up here, and that's at a positive y value. The graph has a maximum. Why not? What would have to have happened for this graph to have had a maximum? It would have had to go up and down, which would have been represented how in the equation? The A would have had to have been negative, okay?